Hi everyone, today we are going to learn or discuss on the topic polynomial of class 10. First of all, let's discuss the definition of polynomial. What are polynomials? Polynomials are algebraic expressions in which the power of the variable are all whole numbers. So, polynomials are algebraic expression. What kind of algebraic expression? In which the power, here the power is very important, the power of what? The power of the variables are all whole numbers. The power of what? Variables. What should be the power of the variables? It should be whole numbers. Let's give an example. Let's say 3x square minus 7x cubed plus of 12. This is an algebraic expression. This is an algebraic expression. Now we have to check whether it is a polynomial or not. Yes, according to my definition, according to the definition, what does it say? It says that an algebraic expression will be called a polynomial if the power, we are going to look at the power. Remember, power of what? Power of the variables. And what are we going to find on the power of the variables? We are going to find whether they are all whole numbers or not. Let's check. Here, in this algebraic expression, we have three terms. In the first term, there is a variable. What is the variable? X. What is its power? The power is 2. In the second term also, we have a variable. This is also x. And the power is also 3. Now, we know that 2 and 3, they are all whole numbers. In the third term, there is no variable, so we are not going to look at its power. You can see that the power of the variables involved in these expressions are all whole numbers, as they are 2 and 3. 2 and 3 are whole number. Therefore, this expression, this algebraic expression, is a polynomial. After we learn what are polynomials, let's learn some other terms of the polynomial, like degree of a polynomial. Degree of a polynomial. So what are degree of a polynomial? The degree of a polynomial, or to find the degree of a polynomial, is again very easy. The degree of the polynomial can be located by looking at the powers of the variable. Now, you can see that in this example, in the given example here, let's check the power of the variables in each term. In the first term, the variable x, the power is 2. The variable x, the power is 3. We know that the power of the variable are 2 and 3. But the degree of this polynomial, what are degree of the polynomial? The degree of the polynomial is the highest power of the variable involved in the expression or involved in the polynomial. That means for this particular example, the power of the variable here x is 2 and here the x is 3. Which one is bigger, 2 or 3? I hope 3 is bigger than 2. Therefore, for this given polynomial, the degree is 3. So before we write the degree, let's come on the definition of the degree of the polynomial. How do we define degree of the polynomial? We define the degree of the polynomial as the highest power of the variable involved in the polynomial. So, let's give an example here. Example of a polynomial. Then we're going to find out this degree. Let's see. 33 y minus 7y cube plus 12y square minus 5. Now we are going to find the degree of this given polynomial. In order to find the degree of the given polynomial, as we have already discussed, the degree of the polynomial is the highest power of the variable involved in the polynomial. That means we are going to look at the power of the variables only. How many terms do it have? It have 1, 2, 3 and 4 terms. Out of this 4 terms, let's check the degree of the variables on the first term. Now here the variable in the first term is y and its degree is 1. If no degree or no power is written, its power is 1. In the second term, the power of the variable y is 3 and that of the third term is 2, and in the fourth term there is no variable, so we are not going to consider this. Actually, if you want to know, even though it does not have a variable, we can consider the power of the variable in the fourth term to be 0. But let's forget about it, we'll learn in the coming classes. Now, the power of the variable here is 1, here is 3, here is 2. So which one is the biggest one, 3 or 2? Obviously we know 3 is biggest. Therefore, degree. The degree of this polynomial, how much is it? Degree, how much? 3. The degree of this polynomial will be 3. Now, when we learn polynomials, we learn degree of a polynomials. After that, we would like to learn about the leading term. We learn about leading term. So what are leading terms? In a polynomial, there might be 1 term, 2 term, 3 term, 4 term, or infinite numbers of terms, many terms. But among that terms, in that polynomial, only one term is going to be called the leading term. So let's check. So what are leading terms? Let's come to this definition first. It's quite simple again. The term containing the degree of the polynomial. The term containing the degree of the polynomial is called the leading term. Let's take this example itself. In this example, in this polynomial, we want to find the leading term. But what does its definition says? It is going to be one of these 4 terms, but which term? Particularly which term? The term containing the degree of the polynomial. Now let's see which among these 4 terms contain the degree of the polynomial. For that we need to know, or we need to learn how to find out the degree of the polynomial. We already know that the degree of this polynomial is 3. That means the highest power of the variable involved in this polynomial is 3. So in which term does the highest power 3 occurs? It occurs in the second term. Therefore this whole second term is what we call as a leading term. That is क्या होगा? minus 7y cube. It is the leading term. After we learn how to find out the leading term, let's learn when will be a polynomial called monic. So we are coming on the monic polynomial. Monic polynomial. polynomial is called monic. A polynomial is called monic. When does it is called a monic? If the coefficient of the leading term is no. यहाँ पे लिख देता हूँ. There's a lot of confusion when we say one. When we say one, the students, okay, the children, they're looking at the figure 1 only. But here, yes, I know most of you know what is the meaning of 1, but there are some confusion in hurry. So let me tell you, let me clear the thought. 1 means plus 1, not minus 1. Okay? So if the coefficient of the leading term is plus 1, it's going to be called monic. That is, a polynomial is going to be called monic. Let's see for this particular example here. Okay? Let's see for this particular example, we are going to check whether it is a monic polynomial or not. In order to check monic polynomial, we need to learn the degree of the polynomial. We need to learn how to find out the leading term. Then we are going to learn how to find out whether it is monic or not. Yes? We know that the degree of this polynomial is 3. Therefore, the leading term is minus 7y cubed. So, we are going to find whether it is monic or not. The leading term is minus 7y cubed. So, what is its coefficient? The coefficient here is minus 7. Minus 7. Is it plus 1? Why I am asking plus 1? Because the definition of monic polynomial says that in order for a polynomial to be a monic polynomial, the coefficient of the leading term should be plus 1. But here in this case, the coefficient of the leading term is minus 7. Therefore, the given polynomial, let's say 33y minus 7y cubed plus of 12y square minus 5 is not monic. It is not a monic polynomial. Let me give you the reason why it is not called a monic polynomial. That is the coefficient of the leading term. There is the coefficient of the leading term, that is minus 7y cubed is minus 7, which is not. The coefficient of the leading term, constant leading term, minus 7y cubed is minus 7, which is not minus 1, which is not, sorry, plus 1. तो यहाँ पर इस पोलिनोमियल का लीडिंग टर्म जो है, इसका कोएफिशिएंट जो है minus 7 है, जो कि मोनिक होने के लिए plus 1 होना था. So it's not plus 1, therefore this polynomial is not called a monic polynomial. After we learn what are polynomials, how to find the degree of a polynomial, how to find the leading term, and how to check whether a given polynomial is monic or not, let's come to some more important terms. And let's have some practice how to find the degree, the leading term, and we will check whether it is a monic polynomial or not. Let's see. Let me give some examples. In example number 1, I'm going to give some examples of polynomials. X cubed minus 7x minus of x square in number 2. 2z plus 3z square minus z to the power 4 and 3 y minus of y to the power 5 plus of 3 by 5 y square minus 7 4x plus 7x cubed plus x to the power 4 minus 3. Let's say x cubed minus 7x square y plus 2x to the power 4 minus or plus, let's say, x cubed y square. Example number 6, 2xy plus 9x square y square plus 7x cubed minus 5 to the power 7. Let's check for this polynomial its degree, the leading term, and whether they are monic or not. Now let's first find out its degree. Degree. For Roman number 1, what do we say? What are degrees? What are degrees of a polynomial? The degrees of the polynomials are the highest power. Are the highest power of the variable involved in this polynomial. For the first polynomial, the powers of the variables are 3, 1 and 2, which is the highest. I hope it is a 3. Therefore, Roman number 1, the degree of the Roman number 1 is 3. And that of Roman number 2, or number 2, example number 2, let's check. The power here is 1, 2 and 4. I hope it is 4. For 3, the power of the variable here is 1, 5, 2. So which is biggest? I hope 5. Therefore 5 is 3. Now for the example number 4, the power of the variable here are 1, 3 and 4. Therefore the degree is 4. The highest is 4. Here the power is 1. Here the power of the variable is 3. Here the power of the variable is 4. The biggest or the highest is 4. Therefore degree is 4 again. In 5, let's check. The power of the variable here is 3. Now let's check this example number 5. It's more such kind of polynomial are not there, I hope, in your books, but these are there in the reference book. Now here the power of the variable here is 3, and for this 2x2 y1 x4 x3 y2 here. But you can see that in a term we're having more than one variable. So when we want to check its power or its degree, how do we check? When we find out its power, we're going to add the powers of the variable in a term. We are going to add the powers of the variable in a term. Therefore, the power of the variable in the first term is 3. The power of the variable in the second term, it is the second term, is x2 y1, means the power is 3 here. Here the power is 4, and here in the last term the power is 3 plus 2 is 5. Therefore, I think that the biggest power is 5. Thus, the degree of the polynomial of the example number 5 is 5. Now, for example number 6, here x1 y1 means the power here is 2. Here x2 y2, the power here is 4, and here the power is 3. Now, many a time children or the student makes mistake. They are looking at the powers. They are looking at the powers and sometimes in hurry they say the degree is 7 because they are looking at highest power here is 7, but it is not 7. Why? Because the definition of the polynomial says that the degree of the polynomial is the highest power of the variable. That means we are going to look at the powers of the variable only. Here the power 7 is not the power of a variable, but it is a power of the constant, so we are not going to consider this power 7 to find the degree. So what is the highest power? Here 2, here 4, and here 3. So the highest power is 4. So these are the powers of the given polynomials here. Sorry, degree. After degree, we are going to find out leading term. Leading terms. For the first polynomial, or what's the degree? The degree is 3. So which term contains the degree 3? The first term contains the degree 3. Therefore, the leading term is the first term, that is x cubed. For the second example, what is the degree? The degree was 4. You can clearly see from here, the degree is 4. Then which term contains the degree 4? This one, or the last one? I hope the last one contains the degree 4. Therefore, the leading term is the last term, minus z to the power 4. Now, in the third example, what was the degree? The degree was 5. Which term contained the degree 5? Is it the first one, second? Yes, we can clearly see that the second term contained the degree 5. Therefore, the second term minus y to the power 5 is the leading term. Now, about the fourth example, the degree is 4. So which term contains the degree 4? Yes, the third term contains the degree 4. Therefore, x to the power 4, that which is the third term, is the leading term again. And about the fifth example, the degree was 5. So which term contains the degree 5? The last term contains the degree 5, that is x cubed y squared. And about the last, that is the sixth example, what is the degree? The degree was 4. Let's check where we do find the degree 4. Here, the second term, x squared y squared, or if we add them, the power is 4. So the second term is the leading term. So 9x squared y squared is the leading term. After we find the leading term, we are going to check whether it is monic or not. Monic. Number 1. The leading term is x cubed. What is its coefficient? There is no coefficient. If there is no coefficient, it means that the coefficient 1. Therefore, it is monic. For the second example, the leading term is minus z to the power 4. The coefficient here shows negative. That means it will never be 1. That is plus 1. It will never be plus 1. Therefore, it is not monic. Example number 3, again we see a negative sign in the leading term. Therefore, it is not monic. Now, in the example number 4, the coefficient here is 1. If there is no coefficient, the coefficient is 1. Therefore, it is monic. In the fifth example, the leading term, the coefficient of this leading term here again is 1. Therefore, it is also monic. In the last example, the coefficient of the leading term here is 9, which is not 1. Therefore, it is not monic. So this is all what we have learned today. We have learned about what are polynomials, degree of the polynomials, leading term, and how to find whether it is a monic polynomial or not. Thank you very much. We will meet in the next session. Thank you.